Okay, welcome to AP 1.7, okay, periodic properties. This could be useful for the honors or general chemistry as well. So I am putting a slash and writing AP 1.7 slash honors for understanding the periodic properties of elements. Before we go into looking at what are the periodic properties, we have to understand two important concepts. The one is called as the shielding effect. Okay, what is the shielding effect? And the second one is the effective nuclear charge. So the shielding effect means when a probe on the nucleus is there and then it's surrounded by several shells and you have electrons that is revolving around. So this is not like a perfect circles. Okay, so the shells expand. Okay, the successive shells are larger. So the nucleus is there. The first shell is smaller and then they just expand like as though it is becoming more bigger. So the distance from the first shell to the nucleus is not the same as the distance from the nucleus to the second shell. Okay, so this is this R1 is not the same as R2, and this is not the exact circles. So since it's expanding, okay, the electrons that is far away, okay, they spend more time and they have a lot of energy. Okay, so they try to expand more, and then they might travel and try to expand like is like running horses that they can expand their own horizon. But they are not going to fly away from the nucleus. They are going to be inside the circular orbit, but they are not going to be defined exactly in circle. Okay, so they are going to be far away. So if you look at this electron, the outermost shell, we know the inner electrons are called as core electrons. Okay, the outermost electrons are called the valence electrons. Okay, this is called as a valence electron. Okay, so the valence electrons and the core electrons. The core electrons are going to revolve around and creates what is called as a shielding. So this is like a protective shield that they are creating by which this electron is let loose, and this reduces the electrostatic attraction that the nucleus can easily impose on the outermost electron. Okay, this is called as the shielding effect. Okay, this is very important concept. The second one is called as the effective nuclear charge. So when you compare the outermost electron, okay, and we have the shielding, this is the effective nuclear charge this electron must have felt. But what actually it is saying is there is an actual uh, number, okay, minus the shielding effect, okay, is what the originally the electron is, what it has to be seen. But what it really sees is subtracted by the shielding effect. Okay, so this is what and an electrostatic attraction should have happened between this nucleus and this electron. But since there is a shielding, you have to subtract that to get the what actually this electron is feeling, what the electron is, the electron electrostatic repulsion it gets. Okay, so this is called as the effective nuclear charge, and we know that Z is always going to be a higher number, okay, compared to sigma. Okay, because this is going to have a less number. Okay, and it's always this number is going to be above zero. Okay, so these two concepts are very important trying to understand before we go into the periodic properties. When we go into periodic properties, I have taken all the data from the ptable.com because you have to understand the data. Then only you can, when you compare the data, you will understand the concept very well. So if you look at what is an atomic radius, we know it is nothing but an atom's radius, right? So if you have an electron that is revolving around, and then this radius is called as the atom's radius. So what are we talking about these radius numbers? That means if I have the second shell, this is the radius of the atom because the outermost electron is in the second shell. So if you look at the periodic table, we call each and everything from top to bottom, we call them groups. Okay, so these are called groups. So group 1, group 2, group 13, group 14, group 15. I have removed the D block elements in the middle just to show you data only from left to right. So this is from top to bottom, okay, groups. And then from left to right, we call them periods. Okay, so these are called periods. This is called the first period. the second period, and so on. So period 1, period 2, period 3. So this is group 1, group 2, group 13, group 14, and group till group 18. So if you look at these numbers, you can clearly see that hydrogen has an atomic radius of 53, and then helium has an atomic radius of 31. Now let's look at top to bottom. 53 hydrogen, lithium is 167, sodium is 19. So we clearly see that the atomic radius is increasing. Why it is increasing? Because the new shells are being added. So the shells are increasing size. So obviously the atomic size is increasing. But when you look from left to right, what is happening? You see that the atomic radius from 167 become 112, and then it becomes 87, 67, 56, 48, 42, and 38. So we clearly see some from left to right, it is reducing. So it is decreasing from left to right from period. So from top to bottom is increasing, from left to right it is decreasing. So from top to left to right, what is happening? The electrons are added in the same shell. The valence electrons are added to the same shell. So when the electrons are added to the same shell, the number of protons are also added, right? So the protons, the effective nuclear charge is increased. Okay. So when you write the answers in AP, you should not just write just based upon the position of these elements, because they are here, they are there. That is the reason their values are. So you have to very clearly establish the answer to get full credit. Okay, so this is very important. So what are the things from top to bottom? Mostly this is the same thing is happening. So most of the answers, irrespective of any periodic property, we are going to see the same answers. From top to bottom, what is happening? What is the real change is happening? So I'm going to write the crucial answers. Okay, what is going to happen? New shells are added. New shells are added. Okay, and then the valence electrons. Okay, the valence electrons means the outermost electrons. So what happens to valence electrons? They have more energy, right? They more energy. So they try to expand. Okay, try to expand. Try to expand and being far away, right? Increasing the radius. Right? The shielding effect also helps, right? Because the shielding effect helps this, right? And then we have the effective nuclear charge. The effective nuclear charge is decreasing. So we know that the electrons are far away. The inner electrons are helping them. Okay, it shields. So the outermost electron cannot feel. So what is the consequence here? The first happens is the most important thing is the new shells are first or added first. That is the primary thing. That is the first important one. The second thing is the inner electrons are creating the shielding. So that reduces the effective nuclear charge, by which what happens to the valence electrons? The valence electrons are trying to fly as far away from each other, so expanding the radius. So these are the correct answers that you have to get. Now, what happens from top to bottom? From top to bottom, the valence electrons are added in the same period, okay, or in the same shell, not same period, sorry, same shell, right? So we are going to add, if you are going to add, if you have two electrons here, the second shell, we are going to add the electrons in the same shell. But meanwhile, we are going to add more and more protons here. That is going to create a very heavy effective nuclear charge, and then trying to bring this electrons much closer possible, right? So it increases the effective nuclear charge. Here, the effective nuclear charge is decreasing. Here, the effective nuclear charge is increasing. And by Coulomb's law, we know that F is equal to K Q1 Q2 by T square. Here the charge is increasing. The charge helps the force of attraction, bringing that shell much smaller, right? So these are all consequences that's going to come for all the factors, all the periodic properties. Here in the Coulomb's law, the effect is nothing but Q1 Q2 by D square. Here the distance is increasing, right? So obviously the force of attraction is very less. So when you look at the first, we understood that the atomic radius is nothing but from top to bottom, it always increases. From left to right, it decreases. Okay. So if we can draw, if we can draw, we can draw like this. So it increases from top to bottom, but it increases this side. So we can draw like this. Okay. What is ionic radius? Is not ionic radii because atom can form both cations and anions. Okay. Now, in that case, now we are going to see that both of them are going to have different proton and electrons, right? So if you take any atom, okay, let's take yeah, an atom sodium. So sodium will have 11 protons and 11 electrons. When it becomes a cation, it will have 11 protons but 10 electrons. Now, the cations will always have a smaller size because their protons are more than electrons. But in the case of anion, if you take an example of chlorine, you will have 17 protons and 17 electrons. So here, if it gains an electron, it will become 17 protons and 18 electrons. Now, since one electron is added, it will try to expand the radius, okay, compared to one proton more. So the radius of the anions will always be larger. Okay, so that we have to remember. So the ions will have the greater radius. Next is what is ionization energy? The ionization energy means the energy that is required to remove an electron from the outermost shell. Right? So if you take an electron and I spend some energy to kick out this electron. So the energy required to remove the outermost from a gaseous atom or an ion. So when you look at the values for this, the outermost electron, you look at this 1312, 520, 495. You see that the reason why this is decreasing is because the shell has already become bigger. Then it is easier. The nucleus is going to be more inner, and then the electrons can be easily removed. So the increasing, it is going like this. It is higher at the top because they are very small. Once it gets bigger and bigger, it is easy to take out the outermost electron. But when you look at the left, from left to right, 520, 899, 800, and then increases to 1085, 1400, and then have a slight dip, and then increases again. So we have a slight discrepancy in the oxygen and the sulfur. The same thing happens here. 495, 737, 577, and then 786, 1000, slight dip 999, and then starts increasing. So from left to right, we know why it is increasing because the same answer that the electrons are being added in the same shell and then the protons are increasing. The effective nuclear charge is increasing. So it is very difficult to take out the electron. But if you take out, when you look at oxygen and sulfur, you will see that the electronic configuration, if you look at oxygen, it's 1s2, 2s2, and 2p4. And you look at the 2p shell, you will have one electron, one electron, one electron, followed by another one electron in the suborbital. This electron is unpaired, so it comes out little bit less energy. With less energy, it comes out comparatively compared to nitrogen. Nitrogen, you have to take out the last electron with 1400 uh, joules, okay, kilojoules per mole, but you have to use here only 1300. It's just 100, but 100 difference. But still, this electron can be easily removed because it is this is only one electron which is paired here. Okay, the same thing happens here also in sulfur. The case of electron affinity, it is just exactly reverse of ionization energy. So what happens in ionization energy? You give energy and then the electron comes out. Here what happens? You add an electron, and then the energy comes out. So you add an electron and then the energy comes out. Okay. So this is this process is an endothermic process because you are spending energy. Here, this is an exothermic process because the energy is released. Okay. And this is when you add an electron, it always forms an anion. When you when the electron is removed, then it becomes a cation. Here, when the electrons are added, it becomes an anion. It's an anion forming exothermic process. It's a cation that formed during an endothermic process. Now the electrons are added and the energy is removed. So when you look at the values, you have 72.8, 59, and then 52.8. So when this also, the same thing, it is increasing at the top. Okay, they are the higher the number. Okay, so they are desperate for the electrons. Okay, here it is easier. It is not easy to give electrons. Okay, so here you have more electrons. You can easily get the electrostatic attraction. So if you give the electron, it takes, but with more price. Okay, so it pays more price because it is desperate. That is the reason the value is 72.8 compared to 52.8. If you look at beryllium, the value is 0 because the electronic configuration of beryllium is 1s2. So the shell is full. It doesn't want any electron. So it is not going to take any electron. So the value is full. Same thing with magnesium. Magnesium is 1s2, 1s2, 2s2, 2p6. It is also full. So if it takes electron, it has to take and fill the new shell. So that is the reason the value is 0. The same thing for zeros for all the rare gases. But now look at the boron, 26.7, and then it increases. Nitrogen is 7. Why nitrogen is 7? It's 1s2, 2s2, and 2p3. If you look at 2p3, all the shell is half full. Okay, if I have to take another electron, it has to pair the electron. So it does not want to pair up the electron. Okay, so it doesn't want to pay much price. But look at fluorine, 328. It gives the maximum price because it is desperate to fill and form the rare gas configuration, the electronic configuration of 1s2, 2s2, 2p5. It wants one electron desperately, so it pays more price. So when you look at the electron affinity values, you have to look at the values as the higher the number, the higher it is desperate and it's going to accept electrons. So you know that it is going to be like increasing at the end. Okay? The electronegativity When you look at the electronegativity values, what is electronegativity? Electronegativity is the ability of an atom to attract electron towards it. So if you look at hydrogen, the value is 2.2. And all these rare gases don't even have electronegativity values because the shells are already full and they are not going to attract anything. So they don't form any compounds. Okay. But if you look at uh, lithium 0.98 and sodium 0.3. So once again, the value is going to be very high at the top because they're very small and their electrostatic repulsion is very high. So they can attract other atoms and atoms together. But when they're very, very big, then their value is going to go, electronegativity value is going to go very low. If you look at hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, that is at the bottom, be the least electronegative. But if you look at lithium, beryllium, 0.98, 1.5, 2.8, 2.55, 3.04, 3.44, and 3.98. Fluorine is the most electronegative element, okay, with the value of roughly 4. Okay. So it desperately needs electrons. So it has a very high value. There is an electronegativity scale. Okay. So the electronegativity value also increases. Okay. From here, from left to right. So you should have a very clear picture about all these important properties. Okay. So the atomic radius, what is atomic radius and how it affects from top to bottom. What is ionic radius? Always anions will have a higher uh, radius compared to cations. And then what is ionization energy? The energy required to remove an atom, remove an electron from an outermost shell of an atom, of a gaseous atom or an ion. It is always an endothermic process, okay, that forms a cation. And then electron affinity is the energy released when an electron is added um, to the outermost shell of a gaseous atom. Okay, it forms an anion and is an exothermic process. And electronegativity is an ability of an atom to attract electron towards itself. And the most electronegative element is fluorine, and the least electronegative element is francium. Okay, so based upon the data, you should have a very clear picture. And for all of them, the reason is only these guys. Okay, from top to bottom, the new shells are added. Okay, the shells are becoming bigger and bigger. And so the the shielding by the core electrons now gives the effective nuclear charge that is being created. It's decreased. Okay, that gives a very high liberty for the outermost electron to expand itself. Yeah, that is the reason the shells are increasing. When the shells are increasing, then it is easy to take out electrons. That is the reason the ionization energy is affected. Okay, then it is when you add the electron, they don't want the electron to be added. That is the reason the electron affinity is affected. They don't want to form any compounds because they cannot pull out other elements together. So that's the reason electronegativity is affected. The same thing from left to right. When the valence electrons are added in the same shell, now the effective nuclear charge is increasing. That is the reason they can go and bind with other elements to form more compounds because the effective charge, number of protons is increasing. So since the effective nuclear charge is increasing, they can the atomic radius is decreasing. It is bringing the outermost shell closer to itself, and then it's very difficult to take out electrons because the ionization energy is increasing, and then the electron affinity also is affected, and the electronegativity also gets affected. So this is a very important topic to understand in AP 1.7, where the periodic properties is. Okay, so that's where we stop today. Thank you.